All right, so I think this is recording. Let's take a look at these two problems. They are not equations, they are inequalities. So the one thing that you probably uh, do remember that it's different than equations. If you multiply or divide an inequality by a negative number, then you're going to have to change the direction of that inequality. So that's something to keep in mind as you're doing these. But the idea of isolating the variable, getting x by itself, is the same. So let's jump in and see what number one has here for us. On the left-hand side, we've got negative 30 minus 4x, and that's strictly less than, and let's distribute that 6 to both terms. So I like to collect my x's on the left-hand side and my constants on the right-hand side. So I'm going to add 30 to each side, and I'm also going to add 18x to each side. So 18x minus 4x is 14x. And 12 plus 30 is 42. Divide both sides by a positive 14, and I get that x is strictly less than 3. So if I sketch this on a number line, what does that mean to me? Well, somewhere on this number line is the number 3, the integer 3, and then we've got 4 and 2. So I make a hollow dot at 3. Now, I don't shade that in because if this were less than or equal to, then I would shade that in and make it solid. But it's not. It's a strict inequality. It's strictly less than. The arrow always points towards the smaller number. X is less than 3. That means that I'm going to shade to the left of 3. And so here's a picture, a graph of my solution set. Now they want me to express my final answer using interval notation. Since the arrow is shaded, I have a negative infinity. Our positive infinity and negative infinity will never have a bracket around them, always an open parenthesis, because there is no smallest number. This negative infinity isn't a number at all. It's just kind of an abstract concept. Indicating to go on forever to the left. Now on the right, we come up to 3, but we exclude 3. We do not include 3 in our solution set, so we have a parenthesis about that as well. If we were including it, if this was less than or equal to, if this were a solid dot, we would put a bracket there, but we don't have that. So we have a parenthesis here, and there's our final answer for number one. Now let's take a look at number two. It's going to be similar to number one. On the left-hand side, I'm going to apply the distributive property. So I get 5 minus 20x, and that's strictly less than negative 40 minus 5x. So again, I'm going to collect the x's on the left-hand side and the constants on the right-hand side. So I'm going to subtract 5 from each side, and that's going to give me a negative 45. And I'm going to add 5x to each side, and that's going to give me a negative 15x. Now, when I divide by a negative number, I have to remember that I'm going to change the direction of the arrow. And a negative 45 divided by a negative 15 is positive 3. So instead of x less than 3 like the last problem, I have x greater than 3. So I'll just draw a portion of my real number line. I'll make a sketch, a graph of my solution set. And that graph is going to help me until we get used to writing our answers in interval notation. I would suggest that you sketch it on the graph and then come in, and this is saying that values that are strictly greater than 3 from 3 to infinity belong in the solution set. If you pick any number real number that's in the shaded region and plug it into the inequality, it'll be a true statement. Pick a number that's not in the shaded region and plug it in, and it'll be a false statement. All right, so here's our answer for number 2. Don't be afraid to ask questions. Let me know if I make any silly arithmetic errors, because I can edit these videos and it will help other people. Hope this helps, and I will talk to you later. Bye.